All right, on this video, we're going to go next steps on our project. We've already phased it to length, both ends to clean up. Now next we got to put these holes through. We got that information over here, 250 diameter, 225 deep, which is the length of the part, so it goes all the way through. And then we're going to put this counter bore. We're going to use an end mill for the counter bore, and we're going to put the counter bore in. Now we need to learn about a new part of our lathe that we haven't talked about before, and that is called the tailstock. So that's this piece right here is the tailstock. So I crank it to extend it here. What if I want to lock it? I can lock it here. That keeps this from moving. Okay. So I want to keep it loose. There's a dial on the back here that you can turn and adjust to zero out. So when you come and touch the part off, we can go an exact number or distance in. We will use that when we do the counter bore because it's only a certain depth. There is a lever in the back here that locks it. Now, sometimes the bed or the ways they change size a little bit, so sometimes you have to adjust a little nut underneath here to get this to lock, and you want to lock it somewhere around 11, 12 o'clock. You don't want it to go too far because it doesn't actually lock. So sometimes out here, farther away from the chuck, is not the same as when we get closer to the chuck. So, speaking of chuck, let me back this up a little bit. We have to put the drill in a chuck. So here we have a chuck, similar to the lathe, only this is not R8. This is tapered, and it has this tang here. Now this tang has to go and line up. I put it in so that it's parallel to this slot. This slot is a way that you can use a tapered tool to knock it out if it doesn't come out. But I want to show you a trick on how to eject. So I want to make sure that it is out. I never want to go past this slot. When I see the back of this slot, that's when I want to call it done. This is the slot I'm talking about. If I go too far, this comes disconnected from the screw that's screwing it in and out. This thing will come loose. It won't work anymore. And it is a pain in the butt to fix because you got to disassemble these half clamp things. It's a pain. I will make you do it. So please, don't crank it out past here. The other side of it is, if I go all the way in, there's a pin on the inside so that when I go all the way in, it pushes against the pin, and that's how it ejects this tool. And I'll show you what I mean. So if I try to put this in, let me get the chuck key out of here. If I try to put this in, it doesn't want to go in. Okay? So I have to have this out, and then you actually kind of give it a little slam in. Come on, focus. Come on back. What happened to my focus? There we go. Come on. Okay. So it, that must be my hand that's messing it up. So I hope it hasn't been happening a lot. So it's in tight. If I pull this out, look at that, it just ejected it out. So if it doesn't want to line up, you're in too far, move this out. Make sure this is horizontal. Give it a little slam in. Now it's in. Okay? So, whenever we're drilling the hole, we always have to use a center drill. Center drill has a lead in like a normal drill at the beginning, then it goes straight, and then it tapers out. And so you go until you get about the diameter you want here, or at least somewhere up on this land of an angle. About halfway up is a good size. You always need to make sure that depending on the size drill you're using, that this pilot isn't bigger than the drill. Okay, so I put this in, and I tighten it with my chuck key. And now this should be ready to go. We'll move it up close, we'll lock this, then we'll crank this handle. I go in a little, I back out to peck, so to speak, to break the chip. So I'll show you what I mean. So we are going to have to move this carriage. I'll make a little adjustment here. We're going to have to move this carriage down because it's in the way. But I can't just go straight because this is going to be in the way. So I go down, and then I got to crank my cross slide out. And let's make another adjustment so you can see better from the top. Okay. So I'm moving this out of the way. So that now I can move my tailstock in. Now where we run into a problem a lot of times is the back of the carriage hitting the front of this, and you're not able to go in anymore. So here's my part. Well, good thing I checked it. It's not tight. We're going 1 to 2 fingers. Make it tight. Let me make sure I have clearance here. I do. You can still see. Let me make another adjustment here. Try and make it a little bit easier to see. All right. That's kind of the view you see as an operator. So I put this in close. I lock the lever that's on the back. So now I can't move this, but I can turn the wheel on the back. So I'm going to have to set my RPM. I am in A3, so I am good. I am clear, nothing's in the way, so it's safe to turn on. And what I'm going to do is slowly go in, and I'm going to pack, and I'm going to see if I can zoom us. And that's not too shabby. I lift the lever up because I want to go clockwise towards me. I turn the knob, it goes a little bit. Nice and easy. And look, it's made a little dimple. It's made a little dimple, but I need more than that. I want to pilot and then go up an angle a little bit. So I'm going to go, keep pecking. Like as soon as you see the chips coming out, you want to back out. Now sometimes, this is totally true on the drill, we're going to use, we got this coolant cup. Okay, where can we see it? Let me stop this. It's too dangerous putting your hand in there with it spinning. So here's my coolant cup and brush. So this is non-spill. So if I turn it upside down, it's cracked. So much for that. At any rate, if it wasn't cracked, it's supposed to not spill. Oh well. So I put the coolant cup down here, and I put my brush here so that I can dab it. All right. I'll try and keep my hand out of the way. So let's turn it back on. I see chips, I come out, I wipe it. I go in some more, I see chips, I come out, I wipe it. So the coolant lubricates it and helps you brush the chips off. Go in a little bit, come out. Now you want to make sure I've seen this happen, so you want to make sure that this is out far enough so that when you back up away from your part, you don't eject the chuck off. Okay, because then when you go back in, there's going to be a problem. So that looks pretty good. So I'm going to move this out of the way. Zoom back in so you can see. So what I have is a little pilot inside, and then I have a chamfer or an angle that's going to be a lead-in for my drill. So next is the drill. Same process. Let me come back out. Let me move this over here. So I take my center drill out, and then we do the drill. The drill is important to make sure that we break the chips and lubricate it, because we're going 2 1/4 inches deep. And I want to show you something. So my drill has flutes. Okay, 2 of them. And here's the flute path, the clearance. I make it horizontal so the one blade is here so I can see the chips come out, just like I could see them easily on the center drill. Okay. Is it wrong the other way? No. Is it harder to see the chips coming out? Oh yeah. Okay. So make sure that this thing is tight, otherwise your drill will just spin. That's tight. Put that out of the way. Now I already calculated my RPMs for this size, so that way I don't have to change it. So I'm going to come up close, but I'm not touching. Am I zoomed in? Yes, I am. So lock the tailstock with the lever in the back. It doesn't move, but I can turn. So I'm going to get my coolant back down here and get ready to go. So what I'm going to do is basically I'm going to wipe chips off. Here we go. Wipe it, crank, chips coming out, back it out. Oh, snaky ones. If you get snaky ones, just stop the machine. It gets a little harder once you get past the depth of the pilot. So I go a little bit, I see chips. Now, the deeper you go, the quicker you're going to want to come out and do this, because all that distance that's in there is getting hot, getting packed up with chips, and if you don't, you'll break the drill. Since this is steel, I've seen things get hot enough. I don't know if you notice the smoke when I wipe it when it comes out. See, steam? Alright. Oh, you can't see diddly. I'm sorry about that. Let me wipe from the other side. It was all blurry. I hope I don't have to edit all this, but I will if I have to, so I'll do it this way. So I go in, chips, wipe them off, go right back in, but come all the way out, chips, come all the way out, wipe them off, because if they pack up, they'll break your drill. Dip back in the coolant. When you get to the end, it's going to break through and get easy. But until then, the deeper you go, the harder it gets. And notice, more chips. I'm deep, so now I barely saw chips come out, but I'm pretty deep in this hole now. So I need to make sure there's that one sneaky chip. You can hear the motor changes a little bit because of that load that's being put on it. We've got to be getting close here. Yeah, I can feel it. We're almost there. Feels a little bit different when we're getting to the end. But the deeper you get, a little more pressure you feel. It's a little bit harder to crank the handle. But you got to make sure you get the chips out. If you don't get the chips out, they pack up. It gets too hot. And if you're not actually making chips, it's just rubbing, then it's going to make the drill dull. It's going to make your part harder than the drill. See, now I almost didn't see chips come out, but I could feel that it cut. You got to be almost there, man. See, no chips are coming out. but I know I could hear it and feel it and see how they packed up. I got them close because one full revolution on the dial on this handle is 200 thousandths. So I got to go to 2.250, so that's going to be 10, 11 or 12 turns. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got to be close. Oh. Not yet. Trust me, if you don't lube it, you'll not have a happy ending. Huh? So close. So close. Now, if you didn't by chance make your part tight enough, it could push your part in, and it seems like you never get there because it cuts a little, but it actually pushes the part in a little bit. Oh, there we go. I felt it got easy. So I'm done. Now, let me give you a word of advice. That part is hot. So don't touch it. It's hot. All right, so let me zoom back out. I'm going to quickly show you about, look at all them chips. Those are good chips. They're not blue, they're not brown, and they're actually chips, and that's what you want, okay? It cut. That drill is supposed to cut. That's exactly what it did. Oopsie, I better get this open a little bit more. There we go. So now, I don't have a counterbore tool, and I normally don't like to do this, but I have a double end mill, 4 flute, center cut, so this is perfect for a counterbore, okay? So we're going to grab it on the shank. Don't grab it on the flutes, you'll wreck this end. Okay. So if I grab, and don't jam it all the way back, because if you go all the way back, you'll end up jamming it against the back and bust the little corners off. So slowly I can feel it, I touch, I move out a little bit, then I lock it down. So this is where you have to be careful to be accurate. So remember we looked at our print. It said we needed to be 125 deep. So we're going to carefully, gingerly push this up until it touches. Okay, it's touching the front of my part. Now I'm going to lock it with the big arm. Let's move. Oh, we are out. I'm going to have to move this to show you this. So I made it so we touched up here. We locked the big arm. We have not locked this at all because we want it to move. Okay, it only needs to be a half a turn loose. Okay, so I got close. Actually, let me say get close, and then use the hand wheel to come up and to just barely touch. Like we did on the lathe, we just grab on the outside until we can feel, oh, I feel it touch. Now, right here is the dial. Each one of these lines is 2 thousandths. So I see 0, 10, 20, 30, 40, 50, 60, 70, 80, 100, 110, 120. It goes around to 190 and then repeats to 0. 180, 180 and 0. So I want it, when I've touched the front, I want to set this to 0. I didn't change this, set this to 0. And then now I can back off so I'm not touching this when I start. And then what's going to happen is I'm going to crank this. One full revolution is 200 thousandths, so about a half a turn is going to give me 100 thousandths. But on the dial, I can see 120, so I'm going to go 120, then I'm going to go 2 lines because it's 2, 4. Okay? So, I'm going to zoom in. I'm going to readjust this since you have that. I'm going to readjust this so you can see this, because this is where you really want to see how we do this. Come on. Alrighty. That should work. So notice I'm not touching the part right now. I'm ready to calculate your RPM. Oh boy. 3.82 times 100 is 382 divided by, this is a 5/16 N mil, which is way bigger than the other. So 382 divided by 0.312 is 1200. Oh, we're good. Our speed range is still good because remember we only had 9 choices. So I'm going to turn this on. We're still going to use our coolant. Same game. But we got to watch our dial. Wow. Let me make another adjustment here. Because I want you to see, I got to watch this dial. I can't just watch this. I got to watch this and the dial at the same time. All right? And I'll show you from a distance a little bit first, and then I'll zoom in. All right? So I'm not touching the part. Turn the spin on. Slowly come up. I'm listening, looking. When I hear it, see it, I should be at 0 on my dial. There it is. I touched, I heard it, I'm at 0. Little bit of coolant. Slowly I turn. Notice how slow I'm turning this. See the chip? Come out, break it. 20 thousandths, 40 thousandths, break it. Go back to 40, 60, 80, back it up. If you hear a little squealing noise, that means you've got a chip building up, you're going too slow. 100, back it up. I'm going to watch this. I'm going to dial right in. Remember, I want like 124. So I'm at 120. 2 lines gives me 124. Back it out. Stop. Now, take a look-see. So, what we have here, get rid of our chips, is a nice little counter bore. So that's the process of center drill, counter bore. I'm going to move this back out for us. Get out of the way, cord. All right, so now I don't want to work here. I'm going to back it up. So I'll loosen my lever, back it up. First, take my cutter out. Put my cutter safely away. Now I'm going to eject this. So if you remember, I said, I'm going to crank this back. Sometimes you got to give it a little pop to get it. Oh, there it is. Crank this back out. Loosen this up. Slide this way back out of the way. Take the chuck key and I put it in here. When we do this, we don't lose chuck keys, just hand tight. That's it. Goes up on top of the rack. So, suppose you want to see the part. I would. So, spin it. I grab the jaw to spin. Makes life a lot easier. Pop it loose. And there we go. Look at that. Nice little counter bore. Hole goes all the way through. Now I got to deburr that. And look at it, it's kind of raggedy on the back. Got to deburr that. We'll use a countersink to deburr that. And then just a little bit of polishing on the outside and our main body's all done. Good job.